All right. So what we're going to be doing, what we're going to talk about right now is we're going to talk about reviewing joins, talking about grouping, talking about some advanced grouping, and then talk about analytic functions. Because all this grouping stuff is actually functions. This is all an extension, really, from last time. Last time we talked about single row functions. Now we're going to transition to basically aggregate or multi-row functions. I am going to be using my database here. This is client, so it's my Oracle SQL database. But what I want you to note is that my Oracle SQL database is actually connected off to the cloud. I've actually gone ahead and I'm connecting this thing to that cloud database that I showed you guys last time. I'm reasonably impressed with its performance and what I can do. So I'm going to do that. Now, one thing I want you to note, which I haven't figured out yet, because apparently this technology has changed since the last time I did it, is I have an admin user that is really, really powerful, kind of like the system user in those virtual machines that you guys, some of you guys have. And before, all I had to do is I basically log on a system, create a user, and then try and log on as that user. Well, I must be missing something because I can't seem to log on through the client directly to those users. I'm not sure why. Not spending a lot of cycles on it because I'm actually pretty busy. But it does mean that pretty well everything I have to do from another schema. I have to do from admin. So we're looking at the familiar structure that we are, I hope, really used to now from our textbooks. But here's the thing, these tables, these objects are all sitting in another schema. These objects are sitting in this schema. And you guys that have got your own virtual machines, you're likely creating this schema and putting the objects in there. And then those of you on the cloud databases, you don't even have that. You're basically just your own schema as well. You're logging in there. What do you do when you are in another schema? Let me move this out of the way. When you're an admin or system or HR or some other schema, and you want to go ahead and read from, let's say, the books table. So you can't just go ahead and go select asterisks for books, at least I hope you can't. So, oh, hey, one thing I forgot to do, sorry about this for the recording, but of course I'm going to turn on the line numbers, and the other thing I want to do is bump up the font. So I meant to do that before, but I was too busy feeding my face. So let's get that guy and make the font just a little bit bigger, not super big, but big enough. All right, so I'm going to go select asterisks from books. All right, semicolon for the punctuation. We go, and it's going to basically say, dude, you don't have books. Because I'm sitting in the admin schema, and the admin schema doesn't have the ability, apparently, well, not directly anyway, to, it doesn't have a books. It's got to basically go to the JLDB schema, which is what my little picture is saying. So what I'd have to do here is I'd have to go JLDB dot books. So basically prefix the object by the schema name. If I go now, all of a sudden it works. So that's a very important thing, because a lot of times when you're in a corporate environment, you are not going to log on as the source of the actual objects. A lot of times you'll be somebody else who will have to go ahead and retrieve the objects using the schema name in front. So that's one thing that's important. However, it becomes a little cumbersome now. If I want to basically, let's do the customer order relationship here. So we're going to go customers instead. So I'm going to double click here, go customers. I'm going to go, great. Now, if I want to get customers and orders, I'd have to do the join, and I'm going to have to now type in JLDB for orders and so on, and it's just going to make my example a little bit gross. So many, especially if you remember that these schema names can be 30 characters long, right? And of course, even the table names can be long too. So it's feasible that you could be trying to type and get accurate 61 characters. You don't want to be that person who has to do that. Even with copy and paste, you don't want to do that. So there is a way to make this simpler for me, and that is to go create a create a synonym. Hopefully you remember that. Create synonym customers for JLDB customers. Now, I could do that. And then now all I got to do is go select asterisks from customers. And it works. And I'm sure we've talked about synonyms already, right? Just give me some sugar if I didn't. So you remember.
You might have called them, I think I've also heard them called aliases.
Yeah, but don't hear them called aliases because that is not ANSI. Synonyms is what they are. Because you might be thinking of this idea where you go select asterisks from customers, because Adam, your brain is actually going on the right thing. This is where we use the table alias, right, with the joins.
Yeah.
Right. And, well, let me actually do my job for a second. I'm sure those synonyms were in the chapter that we talked about other database objects, I think. All right, well, I'll check into that, but you'll get a little bit of a discussion now anyway with synonyms. So synonyms are a way for you, actually what Adam was saying, it is a way for you to sort of apply an alias to the object. Let me quickly show you what the database is thinking. When I go select asterisks from customers, right? Remember, there are no, well, actually, don't remember nothing. You don't know anything, you're a database. The user's gone ahead and done that. So the first thing the database is going to do is it's going to go to the metadata. It's going to go select asterisks from user objects where the object name is equal to customers, because it's got to know what is that thing, because right now there are actually there's 5 or 6 possibilities as to what customers is. It doesn't necessarily have to be a table. So I'm going to do this. It's going to go, and it's going to say, aha, customers is a synonym, right? It's not a table, it's a synonym. So it goes, okay, I know what it is, so I'm going to go select asterisks from user synonyms where the synonym name is customers. So that'll be the next thing it does. So I'll tell you, I'll pin this one. So this is basically user objects. It now knows it's a synonym, so it looks at the synonym, bang. And I did that wrong. Quoted strings, not, there it is. All right, recorded for all posterity. Let's do it again. And now the synonym customers is a synonym for that schema, that object. So then what it does is it goes select asterisks from jldb.customers, and then we get the data. Now, even that's not 100% true, because what would actually happen is it would probably then start going to user objects in JLDB and say, well, what is that? Is that a table or what is it? Because you can create synonyms for other objects as well. So it'd be a similar story here. Go to the JLDB schema, say, what is that? And then it would find out it's a table and then run. So I kind of just skipped a step, but that's what it would do. So my point to this whole story is that by creating a synonym for customers, I no longer have to type JLDB in front of it. It just simplifies my model a little bit. And a lot of times what we do is we'll take objects that have really incredibly gross names. In fact, you can get a hint as to what gross names when you look even at the name of the database. I mean, look at that. That is a legit name, computer generated name, but it's a name. And so, what I would do is I would give it a synonym of maybe ATP Cloud. That, by the way, means Autonomous Transaction Processing. So ATP Cloud is probably what I would do. Give it another name. All right. Now, that's awesome, but it's going to be kind of gross for me to do that for every single object. So what could I do? And so remember, some of your futures are going to be as DBA types, right? I'm well aware that some of you guys want to grow up to become developers. Some of you want to grow up and do more database stuff, but not necessarily DBAs. Some of you just want to go off and waste your lives in networks. I'm just kidding. Networking is a noble profession. But some of you want to, do all this kind of stuff. You got to get to the idea of scripting. And as soon as I realized I was going to have to create synonyms for all these things, and I realized I might want to do this again, like maybe the next time I teach this, or if I'm going to continue using this database, I thought, what would I do? Now, I could just obviously copy and paste and all that, but I wanted something a little bit more generic. So I wrote this. I'm going to run it quickly as a script, and then we're going to explain it, all right? And I'm going to go just run it. Bang. Now, actually, one thing I probably should have done is let's comment that out for a second, because I just did that so that I could, okay, where's my comment? comment. I know I got one right there. Comment. No, that's commit. That was a comment, was it? Come on. Oh, you know what? I could have just done this by now. There is a way, but now I'm starting to get rusty because it's been months. All right, let me run that again. Again, just the way it is. So what I want you to notice is it creates the code for me, right? So what I did is I basically went to all tables where the owner is JLDB. And now I'm sure you guys can probably figure out what happened here. If I go select table name from all tables where owner is JLDB, we start to get this list of tables here. And so what I did is just a little bit of finagling. I know what the command is, and I got SQL to generate SQL. Now, the thing is, if you just run it like this, so I'm going to run it just like this, I end up getting a header, and I end up getting feedback. So I don't want any of that. So the way the script goes is it sets the heading off, it sets the feedback off, and then when I finish, I want the environment to be left the way it was. So I turn the heading back on, and I turn the feedback back on. And then the only other thing is to make sure you clear the screen when you start, so that when I run it, I do this. Now, what's really cool here is that if I want now, all I got to do, I'm sorry, is there a question? There are chats. Chapter 6 or 7. Thank you. So I think if everyone's in, I might actually, I got an iPad here that's basically tracking the participants. So what I might do is shift it over and now track the chats. So anyway, so what I can do, because this is fun, but I can, if I click on this button, it'll take this script, or this output, I should say, and load it, and now I can actually execute it. And now what I've been able to do is create a quick script. It was pretty quick to do, and even with some minor alterations, I could basically go into some other environment and basically say, I would like to have synonyms of all the objects in here, or at least the tables, all the tables in here, without the schema name. So now what I can do is, in here, I can go select asterisk from books, and I got a nice synonym for books. All right, so the point of this last few minutes had nothing to do with joins or anything, but recognizing, again, your ultimate destiny, trying to work with these databases and stuff. If I had like 100 tables or 50 tables or even this many tables, I would really appreciate a script like that. That would just basically generate code. Now, this bit here, which I left in, I mostly did that for you guys because obviously I don't trust myself. So I created the script first, ran it a couple times until it worked. And then basically this was the cleanup. So what it would do is it would give me a nice little drop. And I tell you, no. I think my instincts are starting to come back. Are my instincts coming back? Let's see, hang on. The book screwed up my mouse. So if I do that, look at that. My instincts are coming back. Okay, so if I ran it like this and I go, what I get now is I get all the drops. And that way I can start with a nice, fresh environment. Anyway, there you go. All right. That's all I wanted to say about that. So now let's get back to the actual class now. And if anyone's interested, by the way, I'll be more than happy to try and put a script like this up there. It is pretty unique to the context, but the idea of using a script to generate a script is all over the place when you're dealing with databases. So, all right. What I'm going to do is, what the heck is going? Are you kidding? Okay, right here. This is my mother calling me for the second time today, even after I texted her telling her I was teaching. None of you are mothers, but it's really irritating. And that'll be captured on video. Okay, so here's the deal. I want to basically go and get from customers to orders. We're just going to go straight join between these two tables so I can talk a little bit about this and then eventually get to grouping. So we got customers, we got orders. What would be the join condition I would want to connect these two tables together so I can get the information of the customer and the information of the order?
The customer number?
It would be the customer number. So, 1 second, let me just tell her off again. Teaching, boom. All right, so customer number, right? And actually, notice in this case, it is a number. I can't remember what schema it was that I talked about that it's not a number, but it's a number. Now, if I'm going to actually seriously do this kind of join, and I don't necessarily know where I'm going, and what I should do, by the way, is print out the ERD so I have it in front of me. Oh, actually, no, I don't have it in front of me because, never mind. What I should do is I always like to join from the outside in. Remember, customers are basically a prime table or prime entity. Customers exist outside of the database, right? When the database goes away, the customer will still be around. Orders not necessarily. So I'm going to go from sort of a prime to sort of a characteristic, I think, right? And then this is characteristic. This is also prime. And then right in the middle here, we've got something. What is it called? A table that basically connects these two together. This is called a
Associative, right?
associative. Look at that. There you go. A little piece of job satisfaction. An associative table. So I don't think we're going to go as far as that, but that's just so you know. So get orders of customers. So when I'm trying to do a query like this, I spend a lot of time on the engine first. So I don't spend too much time on the projection. I just want to get the engine to work, which is what I call the from clause. So I'm going to go customers. I'm going to just run that thing, and that thing works. Make sure that I got an object. Great. Next thing I'm going to do is I'm going to do a cross join on orders. This is, it is orders, right? No, it's not orders. It is orders. Okay, I don't know why it's freaking out. So I'm going to go. Now, cross join wasn't really, or maybe it was, I can't remember if it was in the book or not, but cross join just basically is a Cartesian product. It joins every row of one to every row of the other. Most of the time, you don't want that. Every now and again, you do, but it is incredibly rare, all right? But what I'm trying to do at this point is just make sure that my table names are accurate. If you're still one of those people that are typing ginormous long queries from beginning to end and then running it, you're not going to survive when you go into the industry. You need to build and build and build and just validate as you go, right? So now I don't want to do a cross join. I want to do an inner join. So how do we do an inner join between these two tables? We were just told we're going to join it on a condition. Now the book did use a couple things that I kind of cautioned you on. One was going in natural. So instead of an inner, I guess I could have gone natural join, right? Which is totally legit, and I get why they would do that. But a natural join, what that's doing is it's joining on all the columns that are in common. And by in common, they just have to have the same name. So in this case, customer number, it would join just great. Now, if they had chosen to call that zip instead of ship zip, it would also be joining on zip as well. So where the customer number was the same and the zip number was the same. And you wouldn't necessarily know that. I wouldn't necessarily know that, and I've been doing this for 25 years. I don't think you would necessarily catch that was actually happening with a natural join, or at least you'd be looking for that. So that's one of the reasons I don't like using a natural join. The other way to do it is to go join using customer number. All right, join using customer number. And we can go. And again, that looks actually pretty clean. And you could use that. What that does is it just means that if you're, well, actually, hang on a second. We're not quite ready for that. So let's talk about table aliases in a minute, because I'm going to have to start building out my select clause a little bit more. So I'm going to call the customer C. I'm going to call the order O. This should still work without a problem. Great. I now want to have the customer last name. So customer last name, customer dot first name. And I think I'm going to be going in the direction of the city. So customer, right? Is there enough interesting stuff happening there? Yeah, I think there is. City. Okay, city. All right. What do your instincts tell you if you want to have everything in the order table, like everything in that row? Yeah, just everything in that row. What would be a quick way to get everything in this row added to that projection? It'd start with O, but it would be asterisks.
Oh, I was going to say, wouldn't you want like Outage? Oh, okay.
Oh yeah, no, I'm just trying right now. Just get I see where you're going. I'm not talking about necessarily getting every row. I just mean the whole row, right? So I want all of order, all the orders, not just basically picking the individuals. Adam, yeah, you're definitely thinking about the. I want all customers, even if they don't have orders, that kind of thing, and that would be an outer join. But at this point, I'm focusing the projection. I just want you guys to be aware that look, you can do this kind of stuff. Like if you know what the columns that you want are here, but you're not entirely sure here yet, this is not a bad idea. At this point now, except I'm missing something because that's not a comma. That's a period. So let's do that. And this is why I don't like using. It's mad because actually let me do this first of all. This is what I'm gonna do.
Grant, isn't it using a reliant on the column name when you pull the table?
Well, here's the thing. Look at how this works, right? But if I go C dot, it doesn't work anymore because a column part of the using cannot have a qualifier, cannot have that. And that's why I've never really fallen in love with the using, because the reason this is blowing up is because I like to see all the columns in here. And as we well know, customer number is in there. So I'd actually have to list off every single column except customer number to get this to work. So it's a lot more work for me. So I don't like it. So here's what I'm going to do. I'm going to do the join the way I want to do the join, which is by using the on. I like the on. I think it's nice and explicit. Sure, it's a little bit more code to type, but then I don't have to struggle with it later because we could have been dealing with customer number in the where clause in a minute, the group by clause, the having clause, the order by clause. As soon as someone sticks a qualifier on it, the whole thing stops working. And so that's why I don't like it. I'm sure there's a reason why they did it that way. And remember, that's ANSI standard. So I'm sure there's a reason why the whole governing body of SQL decided to do that, but I don't like it. All right, so now if I bring back my thing, and I get the order number. So now what I'm getting is all the customer information I want, plus now all this order information, which is awesome. Okay. So.
Okay, so I just had a quick question too about doing joins. So I know when I was doing the homework, I, for some reason, had it in my head that I had to basically navigate from customer Okay, so there's a table in between the two tables we just joined, right?
Not these two.
It's okay, never mind. Okay, yep. So if I wanted to join that JBL order items, I'd have to join customers to orders and then orders to the order items, right?
Exactly. And
okay. I did have to. So I couldn't go customers join order items because they're not connected. Okay.
Right. They're not connected. They're not connected. Now, guys, I want you to remember that this ERD is like a roadmap. And I know that, it was probably late in the last class that we did this, but if I wanted to basically get from, find out what author was read by what customers, right? So who's reading J.K. Rowling, for example? If I wanted to actually find that out, I would basically have to go pick my direction, but basically go customers, join to orders, join to order items, join to books, join to book author, join to author. And these guys are the associative tables. They're the ones that associate author to books and books to orders. And the only reason we don't have an associative here is because although a customer can have many orders, an order cannot be placed, the same order can't have multiple customers on it. And so because of that, we have a nice straight one-to-many here. But most of the time, your life is spent navigating through these intersection or associative tables.
Okay.
Oh, exactly, Adam. Yeah.
I only asked because my eyes didn't really focus right, and for some reason I thought that you were joining the table. You were joining the table that's actually labeled order items. So that's why I asked.
But I'll tell you this, guys. I've been talking about these kind of join things. I said 25 years, but I think even that's wrong. I think my learning under pressure thing happened somewhere in the I think 95, even earlier. So earlier. Yeah, it was about Anyway, it was 93. Now that I'm thinking about it. So remember I had to learn all this kind of crap without internet and even without books, right? They didn't teach us in college. So it's basically in a hostile environment with people basically saying, hey, I could do this in 15 minutes. I'll give you 2 days. And all I had to do was look at other people's SQL. And joins, groupings, those are the things that messed me up quite a bit. I eventually figured them out, obviously, but they messed me up. So Adam, I know that in your case, you're just saying it was your eyes, but I know there's definitely other people there that are still a little confused on this. And that's why I want to take that opportunity to sort of explain that.
Yeah,
So,
it's taken me pretty much this, like, from the time I first learned about databases to now to totally like get my head around join.
Yeah.
So
Yeah, and the best way to really get your name or mind around is to actually explain to other people. That's the best way. It's the best way. So, okay. So I don't want to. I guess one thing I should do. Actually, you know what? Let me do the outer joins in a minute because I want to start talking about groupings, and what we'll see. I'll start to be able to use outer joins in a minute with the groupings. So let's imagine now that I just want to try to create a report which I've got the customer stuff, the city that they're in, and I just want to have a list of the order numbers. I don't really care about the rest of this stuff. So what I'm going to do is now that I kind of have an idea what I'm looking at, I'm going to go order number, and I go. All right. So now I've got a nice, straight, simple projection. And obviously I could do some where clauses here, right? I could basically pick only people that are, or maybe not East Point, or pick people whose name begins with M or something like that. But now what I want to do is I want to get into aggregation. All right, which is kind of what this what this was about. So before I do that, let me just go over. Okay, I think I've saved this somewhere, but just in case I haven't, let me just move that next to it. Let me talk a little bit about the difference between a single row function and a multiple row function. So if I go last name from customer and I go, we should get a bunch of last names. If I got this customers, probably grant customers, okay, go. All right, so last name customers, good. If I want to change the case on these things to lowercase, I can use a single row function, a single row case function, or character function, I should say. That basically converts this thing to lowercase. This works on every single row. Got it? So every single row that's in the data set will get a result for every single row. Compare that to this one. There's a function out there called count. So notice here, I got at least 20 rows. Now when I go select count, I get 1 row with 20 in it. So what this did is it counted up all the rows, or I could have even said count all the last names. I want to really keep it with the other example. I said count all the last names, and it shot out one answer back, right? It basically shot out the result of that row. The result of the count. So that's why it's called a multi-row function. Instead of it basically giving one answer for every single row, it took all the rows and aggregated it to one answer. And that's what that is. That is 20. Okay, so count is an example of a multi-row function or an aggregate function. So you can certainly count columns. What's usually more common is this. This is your standard way to basically work out how many rows are there in the customers table, how many rows are there in the orders table, right? That's basically how that works. Now, let me just go back for a second. Do we got a dollar figure in there? Looks like we just got ship cost as a dollar figure in there. All right. So if you don't mind, I'm going to flip over for a second to order items, just for this example, because I want to bring up dollars. So order items. Let's see about that. Did it work? I think it did. Okay, so there's 32 order items. So 32 of these rows. So an interesting question might be, how many books are we actually selling? How many books? So assuming that quantity is like, they bought like 3 copies of Harry Potter, right? The quantity would be 3, and the ISBN would be Harry Potter's ISBN. So I'm going to say, instead of count, let's count up the quantity. Okay, so we're going to count up the quantity. So we're going to count up the quantity, and we go. So there are 32 quantities, which certainly makes sense, right? Because it's, you know, there's 32 rows, and each row's got a quantity. That's a key, by the way. Each row has got a quantity. So so now because of that, it's 32. Now, typically, you don't usually want to count up something like quantity. You probably want to add it up. And so the aggregate function for that is sum. So in this data set, we've apparently sold 40 books. So that is the sum. And if you wanted to alias it there, I'd basically say total books. And there's a nice, nice little query, relatively meaningful. It looks like paid each is how much we spent on them. So let's go back over here, and I can add the sum of paid each. Let's just test that dude out. And of course, I did it wrong because paid each is not the underscore. Paid each. So this is the sum of all the books that we bought. Using a single row function, I could convert this to a character, and this is Oracle specific now what I'm showing, but I can convert it to a character, local currency, local grouping. Oh, did I use comma? That was bad. G. Okay, you know what? Case isn't important, but you guys know me enough now to know that I like to do that. All right, so let's do that. This guy's now going to look like money, and now I can basically say as total sold. And that will give me a nice little query there. All right, so sum is a multi-row or aggregate, and then what comes out of that, the single row function kicks in and converts it to a character string of that format, and that's why it now looks like money. Okay, so other things that we could be doing with our aggregate functions. I don't know how many of you are familiar with aggregate functions, but there are a few other things we could be doing with them. So here's what I'm going to do. I'm just going to get myself ready, and we're going to basically see the same thing over and over again. All right, so there is something called average. Average is basically giving us the average cost for the book. So I'm going to, at this point, go average sold. Okay, there's, I may as well keep it consistent. There is something called max, which will give us the largest, so the priciest book that we sell in that data set. And with max, there's also a min. And let's get that guy there. And let's go. And so what we're getting now is the most expensive book was $85. The least expensive book was $8.95. And let's see, was there another one that I wanted to show in this data set? So there's a sum we talked about average, talked about count. It's funny that they don't start with count in the book, by the way. I thought that was kind of interesting. Max, min. Well, you know what? Other ones, at least one other one that would be interesting to you, perhaps, is standard deviation. That's for you statistics nerds. So I'm just going to go standard deviation. That will basically show what the deviation is from the average. And then there's also variance, which I'm not going to bother showing. I think there's a mode as well, if you want to know what is the most common common book cost. So anyway, so there's all that. So we've got a lot of different aggregates now. Average, sorry, sum, average, max, min, and standard deviation. Those are definitely in your books. Now, you'll notice I did all this on numerical data, right? I did all those on numerical data. Is there something here that's, well, there's no date, which is unfortunate. So I tell you what, let me just leave this query for a second, go select asterisk from orders. There's a nice date in here that's good to look at, and that's the order date, right there. There's our order date. So I could say, what is the maximum order date right? So what's the maximum order date? And what's the minimum order date? And what do you think that's going to tell me? Basically, when was the first time someone ordered a book, and when was the last time someone ordered a book? So the max, this is the most recent sale, and this is the least recent sale. So we've been apparently in business for a whopping 6 days, it looks like, 5 days. So that's basically the point there is that maximum works not just on numerical data, but it works on character and date and even other kinds of data. Count would work on pretty well everything. Like if I basically said count. Remember, count was count asterisks at one point, right? So count definitely works on any kind of data type as well. All right. Cool. So you guys feeling okay right now about aggregating the entire table and what these are doing and why they're called multi-rows and why they are called aggregate functions? They aggregate the information, okay, put together. One of my first challenges as a young programmer, effectively fresh out, I was out about 2 or 3 years, was that someone was using the word consolidate. And they never explained to me exactly what they meant by consolidate. So I basically started grouping things together. It turned out what they actually meant was aggregate. But that was after I'd already been coding for now 9 months at that company. So this bias I had about grouping together, it was a bad scene. So you know, get to know your terms. So aggregate, multi-row, right? Aggregate, multi-row. All right. So now let's go back to this query over here. And what I want to do now is I want to know how many orders does each customer have. Okay. So I'm going to strip off the first name just to make it easy. I'm keeping city in here for a second. So I now want to know how many orders does each person have. I would go count this, right? Obviously you put a count there and that'll give me how many orders, and yet that'll give me an actual error for a very neat reason. So let's go back to a simpler time, and let's just go and do a simple query and find out why that didn't work. So this thing here, I'm going count order items, and it basically is fine. If I added another column, ISBN, which is this one right there, ISBN, and run that, it's going to blow up again. Actually, you know what? Let's not use ISBN. That's kind of dumb. Let's use order number. Order number we'll use. That might be a little bit more cool. So order number. So what this is kind of what I'm trying to do here is find out what is the total number of books on each order. That's the English. Always think of the English behind a query, by the way. So that is the English. What is the total number of books in every order? So if I go, it basically says, dude, you can't, because it says now not a single group function, which is horrible. But what it's trying to say here is that you've got something up here that you're not aggregating by. That is not a group function. So we need to actually add a whole new clause now, new to some of you anyway, group by order number. Now I know, in theory, I hope you encountered this idea in the previous course, but we're going to try and understand it a little bit better in this one. So now, if I go run, I am actually going to get now the fact that some of these orders have got more than one book in them, right? Because I'm grouping by order number. Now, if I was to slip in another key, let's put in the item number. So the item number, yeah, sorry, I just had a memory leak there. So item number, sure. And I go, it's going to be mad again because item number is not an aggregate function and it's not being grouped by. So what I need to do to get this to work is anything that's not an aggregate function has got to be in the group by clause. This will not give us too much cool stuff at this point, by the way. I know apparently, actually, I guess what it's saying is that this guy has bought 2 of the same book. That's kind of what this guy is saying. But anyway, it doesn't matter. I don't want to get too much into the logic there. What I'm trying to say is that if you've got something in your projection and it's not an aggregate, you have to group by it, or you're going to get that error. All right. So back over to my example here, I'm trying to basically do a count of the number of orders, but I didn't say anywhere in here how to group by it. So I've got to add that column, group by. So group this data by the customer number, last name, and city. Once I do that, now we're getting really close to a meaningful report again. So Guyana bought 2 books. Mostly people, by the way, are not super big readers, but anyway, they basically bought 1 or 2 books. That's kind of the deal there. All right, so that's important. The group by clause is definitely important, right? You can, as soon as you slip in any aggregate, you have to group by anything that you're not aggregating. All right, so that's the thing there, and that is sort of discussed a little bit now on 413 and sort of demonstrated. But we now have a problem. I want to see all the people that have bought more than 1. Oh, not these aren't books, right? These are orders. So okay, so maybe they are avid readers. They just managed to buy a bunch of books at once. So what we know now is that Guyana has at least bought 2 things from us. Fla bought 2 things from us. Lucas has bought 2 things from us. So what I want to do is I want to isolate the customers that have come back and had 2 orders, right? Because maybe I figure that they might actually like reading or something. So a common thing for people to do, and this tripped me up so much in my younger naive days, is I'd go where, so you guys get what I'm trying to do, right? I'm trying to get basically anyone who's got more than 1 order. So basically where the count of the orders is more than 1, right? Makes perfect sense. And yet when you run this, it doesn't work. And all you get for a crappy little error message, at least it's kind of telling you line 5, so at least you know the error is here in line 5. It says group function not allowed here, but doesn't actually tell you where to put the group function. So I'm going to show you a nice little picture I put together for this, and then we'll actually fix it. So I think life of a query. All right, so let's bring you down a little bit. So this is sort of for another set of data, but it's what we can kind of see here. We're trying to basically count the number of cities, sum of the balance. So this is basically a balance by city for clients, okay? And what they're trying to do is trying to find where the sum of the balance is greater than 6,000. Now, if this is blowing your mind, then don't worry about it. You can just go back to the fact of whatever my example was now. I guess customers and order greater than 1. But what I want you to see is this. In the beginning, so Marvel is actually the name of the database. This is the name of the schema, and then this is actually the table. So when your query is running, I think I've explained to you now a few times that it doesn't all run at the same time, right? Each clause runs at different times. And I think, well, I won't even do it. Let me just go back. Each clause runs at different times. So the first thing that happens is the from clause happens, right? So when this thing gets pulled in, it knows what's in the from. That's why I keep calling this thing my engine. That is the first thing that runs, right? The data set is basically put together and put into the memory of the database. So off it goes. Everything I'm saying is kind of a lie, by the way, but it's close enough. By the time you understand what I'm lying about, you're able to handle what it's actually doing. But notice at this point, it hasn't grouped or anything, so I can't do a where the sum of balance is. I cannot restrict off this because it actually hasn't grouped anything yet. If you look at how this is running, and this has got the answer, the from clause goes off first. The where clause, if there was one, would fire off. Then a group by happens. And so now we've got our groups. And now because we have our groups, we know what the sum of the balance is. And so now we can do a restriction, and then we get our results. That is the only reason the having exists. The having clause is a way to restrict on groups. I could actually say having, I put the having there, because for some reason, ANSI has said that you can put having in front of the group if you want, but most normal sane people do this. Because that's kind of the way that most human sane people think. This will run first and give me a data set, a combination of customers and orders. Then the group will happen. Now it knows what the count is and the sum if there was one out there or whatever. Now the having takes place, and then we get to see what it does. So off we go, and there's that answer. Let's do something here where I'm going to basically say I'm not interested in Macon, just to get that kind of completion here. So I could go where the city, or c.city, is not Macon. Go. So now we don't get Macon. Now I'm going to add another clause that you should already know. Order by the city. So C city. So there's lots of neat stuff happening here. And for you guys that actually were programmers, this would be really different. Well, it wouldn't. Okay, let me finish my point. It would be difficult to do in a lower level language, except most lower level languages have some kind of way to do SQL like properly. Like you'd actually take the SQL statement as a string and throw it in. But if you didn't have that ability, if you actually had to code this, there would be a lot of stuff happening here. First thing, rows 2 to 4 run, we get the data set. And that's kind of what I'm trying to show in this example. There's the data set. Next thing, it restricts on the city. And so we see a nice little restriction that takes place. Next thing, it groups. And so now, right at this point, I've got these rows exist, right? I've got the groups. And so there's the groups. Then the having clause takes place, only stripping off anything where this number is greater than 1. And so now, like, one of the rows disappears. And I guess I didn't show it on my diagram, but then we get the, actually probably what we get, excuse me, is we get this select and then the sort. All right, so there is sort of the life of a query, and that's basically grouping and having. So let me stop for a second and see if you guys have any questions on that. It'd be interesting, and sadly, it's not a great environment for this, but it'd be interesting to see how many people that this information was new. Because I'm always, I don't particularly want to waste people's time by recounting what was done in other courses. I just find that typically, from my experience, usually a lot of students kind of have, you will still apparently have issues with this. So anyway, okay. So that was important, the life of a query. So definitely go out here and I don't know, you probably can't use that SQL statement, but just, have some fun. And let me also, I don't know if I did this already. I kind of think I probably did, but let me just go. This used to be my go-to when I was trying to figure out what clauses actually ran first. And so, because I'm always looking at the line. So of course, right there, it's indicating that it can't resolve this. So line 2 is the thing it has an issue with. So now I go and put in something that makes it work. So there's customers. I go. Now it's mad because of line 5. That's interesting. It's actually mad at the having. Yeah, I tell you, man, things just change. If you don't like change, get out of this industry, because it used to then blow up at the where. And then it would blow up at the grouping, and then the having, and then the select, and then the order. So whatever, that's fine. Okay, so what I would like to do
I have a question for you.
Yes.
So so where would only fire up second if we have having? Otherwise, having will be the second one that would run, right?
I wouldn't read that in. You know what? Actually, read that in. Yes, true. If you did not have the where clause, no. If the where clause didn't exist, it needs to group it first. It does need to group it before the having happens. So I would say if the where clause wasn't there, go from, group, then having. That's what I think it would do. because otherwise it doesn't know what this is. It doesn't know what the count is until it's actually grouped in, right? It'd be basically saying, well, how do I aggregate the data? So.
Got it. Thanks.
Yeah. Now, they do have a little bit of a discussion in there about nesting group functions. So maybe it would be worth it just to have a quick peek at that. But boy, I don't know if I want to do that. What's it actually asking here? It is asking the average order total. Do we really need to do all that to get what we're trying to get there? Okay, you know what we'll do? We'll do something called the maximum average. That's what we'll do. We'll do a maximum average. So let me go to here, and it's going to take me a second to figure out what I'm actually asking. So just give me a bit there, then we'll have a break, have a couple beers, relax. Okay, so I'm going to go off of shipping cost. I don't even know what shipping cost really means, but what we can see there is I can probably aggregate shipping cost, and then I can so I can get an average, and then I can try and get like what is the largest average, right? That would be kind of interesting. Now, a couple of things actually I'm realizing I should show you as I'm seeing this. I'm going to go ship cost, the count of everything, and then the count of ship cost. And I would like you to tell me why the numbers are different. So I'm going to pin this, and if you're chatting with me, I can't see it, but nope, you guys are not chatting with me, so at least I didn't do that. And what I'm going to do is I'm just going to go and have a straight projection and then toggle between the two ideas. So this is the data from a straight shot at it, and this is my aggregate up here. So why do you think I have got the count of rows being 21, but yet the count of shipping costs being 18?
It doesn't count the null values.
It does not count the null values. That's 100% accurate. And it's yet another reason you should be aware of nulls, because this isn't necessarily a bad answer. This is actually totally accurate. I asked how many rows, how many ship costs. And I do only have 18 ship costs because those don't count, right? I don't have those ship costs. So by default, all aggregates will ignore nulls. So if I was to say, what's the average ship count here, for example, or G, average, I mean, that is the average, but it's not taking the sum and dividing it by 21. It's taking the sum and dividing it by 18. So just be aware of that. If you really do want to treat the shipping costs that are empty as, let's say, the value of 0, how would you do that? You guys know? Do you remember?
Hey, Grant, you know what can we do?
What?
We can have them actually have Prime so they don't pay for shipping. What do you think?
I'm thinking I need some of my beers that are just behind me, but I'm not going to do it yet. That's probably unethical. NVL is what I'm going to do. So I'm going to use the NVL. I, by the way, have Prime, so I'm pretty excited about that. But now notice there, my number's different because now it's taking the sum and divided by 21. All right, so big lesson there. The big lesson there is that aggregates ignore nulls. Okay, so that's a big lesson. But now let's deal with this. We want the maximum average. So if I want the maximum average, first I would try to work out, what is the average. And I'm going to take out my NVL now because I want this to get a little bit simpler. So there's my NVL. So what is the average? Now this is giving me the average, but that's not the maximum average that each customer paid, because if you look, right? I mean, that's I don't know what each customer did. So is it customer order? What am I focusing on here? I'm focusing on ship costs would be customers. So I'm trying to focus on customers. So if I then added customer number, I want to know what is the maximum average of shipping cost the customer has got. I go. This isn't going to work because I've got an aggregate and then a non-aggregate. So how do you solve that? We put an aggregate function there. Group by customer number. So now what I'm getting, there's all my customers. Now, go ahead, guys. What is the maximum average from what you can see? Oh, Up in the chat. Looks like, oh,
Or no, 4.
man, happy birthday. We should sing that in database language. Anyway, 4 is the magic number. 4 is the magic number. Okay, I'm gonna get my okay. Anyway, so that's the number. But how would I get that? Well, here's how I'd get this. If I took out the customer number, I would still get a list of numbers. And then I could go, what is the largest of those lists? And 6? Okay, why is it 6? Did I miss seeing 6? Okay, you guys are still drinking on the chat, so that's fine. Let me just get this again for a second because I don't know why it's 6, because I thought it was 4-2. So we're going to group by this, copy, and paste. So I'm just slowly going back to this, and then what I need to do is go average, 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 and I'm hoping there's at least 1/6 there, or I'm going to go crazy. There he is. All right. Phew. All right. So anyway, long way to go, but here's the deal. Sometimes you want to know what is the largest average of something. And so basically you kind of build it up very slowly. So the first thing you'll notice I did is I basically came back with a straight list of customers, and their shipping costs. That was the first thing I did, just so I can get familiar with the data. Next, I wanted to get an average by customer. So I'm going to go and get an average by customer. So then I start to add that. I got an aggregate in there, so I have to start grouping. So I do that. Now I've got customer numbers and their averages. I want to know the maximum number of those. So I need to kind of go like this, maximum average, but this isn't going to make any sense because I've still got customer number in here. I have to basically peel that off, and now I got myself the maximum average. And just so you know, why would you ever want that? Because you can write a query soon, I think even next week. And next week, what we can do is write a query that basically says whose average cost is 6, and then we will actually get the person who has the largest average cost. So that's the idea of nesting a group function within, nesting a group function within a group function. All right, I'm going to pause the recording. And are we still, there you go, we're still celebrating the birthdays, and that's awesome. I'm going to pause the recording, and when we get, when I resume it, I'm going to talk a little bit about some fancier groups, and then I want to talk about analytic functions. It won't be that long. Everything I've talked to up till now is basically what you need for the assignment. The rest of the stuff is going to make you actually good. All right, so I'm going to pause, and let's pick up probably at, I don't know, it's almost 5. Let's pick up at 15 after. All right, so where we are with our heroes is that what I want to do is I want to take this data, and when I run it, I would like to have 1, 2, 3, 4, 5 running along the side of it, kind of like these implicit row numbers, but I want them to be actually part of the data. So there is actually a function out there that can actually do this. That function, it's not going to be this one, but it's going to be close. Rank. And you know, that's right. The order by should get out of there. The order by will get out of there. It's if you're going to rank though, what would you rank it by? You'd order by. Oh, this might be why I don't do this. Look at that. Okay, this won't work, but this is the idea. And let me just run it. It's going to get mad at the single at the grouping thing, or parentheses or something. There's a whole bunch of stuff wrong with that. So here's what I'm going to do. What I'm going to do is introduce you quickly to subqueries and then go from subqueries. So do this. Next week, we're going to learn more about this, but if I go select title and this should be pretty cool if you look at that. What this will do I put an as in there because I'm feeling guilty. This query runs first and produces this data set. And then I basically now select from that query. And what I've been able to do now is basically create a sub-query. More on that next time. But for now, what I want to do is I want to get my rank thing going. I still want to get my number one. There is a cheap way I could do this back with my row number idea, but I don't want to do that now. I want to really charge at this rank thing. This should do it. Still not doing it. Oh, because when you rank, you've got to order by something. So order by total sold. Finally. All right. Okay. So with these analytic functions, they look a little bit weird, right? You guys can handle the idea of, I'm getting there. You guys can handle the idea that with a lot of these functions, we typically have the function name and then we pass something in, right? And so we're seeing up here, rank is definitely a function and we pass something in. Not all analytic functions take an argument. And so rank does not, but soon we'll see other ones that do. But the other thing that's extra special is this clause. It's almost like this over is sort of another part of the function, which also can take an argument. Not all the time. I'm going to show you an example of it not taking an argument. But what this is trying to basically say is aggregate this over that condition or over that input. So rank requires things to be ordered. So it's going to basically order it, and then it's going to rank them. And that's what you're seeing being done here. Now, some interesting things happening even in the rank. By the way, I guess I'm realizing it's ranking how to build a manger as like 1, whereas it's actually the opposite, right? That's the lowest selling book. So if I go descending, just like it would have in the order by clause, I should get something a little bit better. So, okay, so cooking with mushrooms is number 1. Database number 2, 3, 4, 5, 6, 7. We got a tie for 7. Then all of a sudden now we get 9, 10, 11. So what rank does is it leaves holes, right? It leaves holes. It's not necessary. I mean, there's no reason to think that there should be an 8 necessarily, right? Because really, I mean, in the entire data set, it's basically 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, and 11. Most human beings don't like that, though. So a lot of times, instead of having a sparse rank, we'll have a dense rank. Oh, it wasn't. Majors asked why was it 111 before I put the descending in. That was an optical illusion, and I'll show you that. So first of all, here's dense rank. And you can see that it goes 1, 2, 3, 4, 5, 6, 7, tie for 7. So these guys are in 7th place. These guys are in 8th place. And that's typically why you'd use that. Now, let me return it to the way it was without the descending, and I can show you what I meant by that. It wasn't really 1 to 11. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your eyes would see the 1, you'd see the 11, but it was actually missing spots. When I went descending, and I go, it's 1, 2, 3, 4, 5, 6, and then these guys get tied, and these guys get tied. So we lose the 11. So 2 ones that are pretty interesting is rank and dense rank. Okay, so that's definitely an interesting one, and what you do is you do call it as rank. And they do perform pretty well in the database. So that's kind of awesome. Now I want to know, what was the total number of books sold completely? What was the total number of books sold completely? So I got my total sold here, and I want to compare it to the total sold completely. So if I put sum, I'm going to put it on its own line. If I put sum of total sold, this is going to blow up, right? It's going to blow up because it's going to say, dude, you've got things up here that are not aggregates. And in theory, what I'd have to do is I'd have to go group by this, this, and this. And that's not going to get me any kind of answer. But what I could do is go group by, sum it up by the total over nothing. So with dense rank, I'm using the over to control how we're ranking. Sum, I'm saying sum it up over everything, basically. I don't have any kind of thing in there. And so now there's our number 40. So what it just did is it added the entire data set and put it on one line. That would be very, very, very tough to do without an analytic function. It would actually be one of your favorite topics, joining. It would actually be a join that would do that. So sum over everything is it's kind of what's the word I'm looking for? It's pretty cool, because what I could do now if I wanted to is I could actually get a nice little percentage. I could go, what is the total sold divided by it completely? And now what I start to get is this guy was 20% of my sales, right? You know, do a little bit of that two char stuff to basically make it look like a percent. This guy down here is like, you know, basically 3% of my sales. And this stuff makes marvelous pie charts, right? So there's definitely stuff in here that that helps making statistical analysis a little bit easier to do, rather than just pump it out to a spreadsheet. Now, I feel the urge to look at my little handout for a second to see. So there's the dense rank. So what I'm trying to do here is I'm basically taking, and this is an old handout, by the way, but taking sales by city, right? And I'm basically breaking it up by year. Oh, the partition by. I haven't talked about the partition by yet. Okay, I'll talk about the partition by. Actually, you can see the partition by here. If I basically said dense rank over order by, all these values would be sorted, and the rank would be sorting them all from 1 through 12, I guess. But to Major's point, over doesn't just take the order by. I can actually say break it up by the year. That's what partition by means. Break it up by the year. So what it does is it sorts the sales, order by profit, and then break it up by year. And so we get 1, 2, 3, 4, 1, 2, 3, 4. There weren't any ties here, but if there were, we'd see, like, you know, a couple 2s or a couple of 4s or whatever. So that's the dense rank with a partition by. This data I'm playing with right now isn't particularly useful, so I can't do it for that. There's average of whatever I'm averaging. Now, if I said over and I left that empty, that would be the complete average profit. But instead, I'm saying break it up by calendar year. And so what you can see is each section has got its own average. And again, incredibly useful for queries. You can basically say who is making more than the average profit, like which city is making more than the average profit, or even, you know, which is making less. And there's also, by the way, there's max, there's min, there's standard deviation and variance. That's all in here. So all the groups that you know, what makes them special is the over this grouping. Entile is not necessarily that great with this data, so let me do it with this data. So I'm going to just go back to a simpler time without the sum. So let's just do that, go. And now we're back to this. All right, good deal. So what I want to do is I want to break this up into buckets. So let me tell you what used to be a funny story at Oracle, but not so much now that I'm laid off. What they used to do, especially when I was an instructor, is that we had our average rating, right? Our average rating, which was a combination of the scores that students would give us and how busy we were, how we were utilized, and we'd all have a number. And what they would do is they line up all the numbers of all of us into sort of one giant row, and they basically split us into 3 groups. You get the top third, the middle third, and then the bottom third. And guess what they did? They would then fire the bottom third. And in theory, they would hire more people and then reevaluate the next quarter. Top third, middle third, bottom third, wipe out the bottom third, and then hire more people, and they'd rescore again. It was a wonderful time. It was a wonderful time. Especially made more wonderful when we had this many instructors in the beginning, let's say 100. They broke us into 3 groups, got rid of the 33, and then never hired people again. So now we're at like 66 or whatever, and they break us up. So it was 20, 20, 20. They got rid of the 20, and now we're at 40, and then they break us up again. It's not too hard to imagine that although you might have been really safe when there was 100, as the number gets smaller, each bucket, you could easily slip into these other buckets. So that is a percentile calculation. And so what I could do here is, I'm still looking at this to see the way I would do this. Yeah, you know what? You guys already know what a subquery is anyway, so I'm going to go and subquery this. I'm going to go select asterisks from this subquery. And if you think that this is messy, you should again see the stuff I'm looking at. So what I got is I got rank. You should see title, and you should see total sold. So now this query is looking really simple, but it's based on this query, which is based on this query. So we're going to go. So far, so good. But now what I'm going to do is I'm going to go end tile, take this, break it over, let's say 3 buckets over order by total sold descending. So there's our first bucket, there's our second bucket, and there's our third bucket. Percentile. And so it's easy now if I basically say, let's say I want to eliminate the I want to take all the books that I sell because they're taking up inventory, and I realize that no one's apparently buying the books in the lowest percentile. I can knock them out, right? And that's basically where that calculation comes from. So that's pretty cool. Again, separating you guys a little bit there. Okay, lag. Okay, some I've already talked about. So the last two I'm going to talk about today are lag, and then I can't believe I forgot the other one, but lead. Lag means lag behind. Lead means go forward. So, and a lot of times in business, you want to know, how did this quarter compare to last quarter? And so what you can kind of see is that we're lagging the profit by 1. We're lagging it by 1. So what's happening here is that this guy is behind, like it's in, let me try this again. Okay, so you know what, let's just try it first of all in a normal data set. So let's go here. So lag, I'm going to go lag. This won't make any business sense, but you'll actually see it a little bit more clear. I would like you to lag the total sold by 1 over, do I need an order by? I do. Order by total sold descending. I may as well order it by the same way I'm doing my end tile. So, all right, so do that and let's go. All right, and you know what? Let's get rid of this this thing so it looks a little bit closer. Can you see what's going on? I'm lagging this number back by 1. Back by 1, right? Okay, so if I wanted to basically compare for some reason the total sold of this book to the one just in front of it, I could do that with really complicated SQL, or I could use a lag calculation. Now another, its twin is lead. Lead goes 1 ahead. So now it's basically comparing this guy to the 1 ahead, which is 7, 6, and so on. Okay, so there's lag and lead. Because there is no 0. So a good question is, why does it not go to 0? This isn't so much a countdown. It's basically saying compare this row, compare this row to the 1 ahead. And there isn't anything ahead. So it's null. Another good example, by the way, of what null really means, right? Null basically means I don't know, and it's basically I don't know what the number is out on like row 12 because there isn't a row 12. And when we were going lag backwards, we saw the same thing, lag backwards. It's basically saying like 7 lagged by 1 is 8. 8 lagged by 1 is row 0 There is no row 0, so it's null. Nice. So why even do this? Good question. Imagine that I want to compare each quarter for the year in front. Now, in most businesses, we don't typically compare Q4 to Q3, right? Businesses have a sort of a cycle, and you definitely most of the time would not want to compare Q4 to Q1, for example. So a lot of times what we typically want to do is compare the quarter of one year to the quarter of the year previous. And so in this case, we can tell, and I wish I'd spent a little bit more effort formatting this, but we can tell that apparently our sales are down. Yeah, right there, New York. So we're comparing New York last year at this time to New York this year at this time. So actually, we're doing better. So New York is doing better. We're lagging behind. Yeah, so the question is, so most cases it'll be for financial statements or tracking product movement, 100%. I wouldn't say necessary for most cases, but those cases that you want to be used in financial statements and tracking products or student counts, right? It's definitely used to compare the data in usually one slice of time to another slice of time. Yes, I would say that. Good. So, so that's it. So these are all kind of, again, sort of businessy type things. I think you guys are okay typically with the sums and the averages, but I didn't want you to see that there is a way to create a rank, and there is a way to get percentiles, and there is a way to compare one row to another row that had already been run. I had to write, again, in my earlier days, I had to write a program that actually did this, and it was hard. So, so when I saw this thing come up, I went, oh, this is awesome. Because the other way to do this, by the way, would be to have one select statement that basically produces it for one row, one year, another select statement for another year, join them together, right? And then you can do your comparison that way. But now, instead of that, you can do it all in one straight lag calculation. So that is it. That is it. That is all the stuff I wanted to show you today. I want to have a quick look at the homework, but I did sort of scan it before. There is going to be, let's see, you do get to play a little bit with the roll up and cube, so definitely have a peek at that. But yeah, it shouldn't be that bad actually. Yeah, it shouldn't be that bad. Okay, any questions and or concerns?
Yeah, I have a question. That refers back to joins. So with joins that have different column names, I know how to do those, but sometimes I get weird errors. So could you like demonstrate one that, two tables that may not have the same column name and then join them together?
Wouldn't that be awesome? Let's see what I can do, Colleen, about that. So, okay, I'm going to make another table quickly called my order items, and I'm going to rename the column. Okay, so that's what I'm going to do. I think I can do this here. So I'm going to go create table. Actually, I'm going to call it crap order items so that I know that this isn't any good. As select asterisks from order items. And I think, by the way, this will work because of the synonym. So let's do this. So this will give myself another little table called crap order items. And it worked. Awesome. Let's do a join. This doesn't do what you're asking for yet, Khalid, but I got to get there. So I'm going to go select order items and orders. So select whatever, asterisk, we don't care about what's actually in it, from orders, join with crap order items on, and I got to get my table aliases ready to go. So that's O. Oh, don't go A and B, by the way, which seems to be what my finger is trying to do. This is O, and this is going to be C. And I'm going to go on C dot order number equaling O dot order number. And actually, whatever, I'll stop talking. That's good enough. Okay, so let's get this go. Are you going to work? You're going to work. Awesome. All right, so your question is, what if they didn't have the same name? So let's rename that column, which I think is alter table crap, fingers in the wrong spot, crap, order items. Okay, add something called order num, and I'm going to actually give it a different data type. I'm going to give it a char 4. Okay, so it's going to be char 4. Okay, so let's just add a column, and it didn't do it because why? So add, oh, maybe, no, you know what, Grant, your parentheses are all monkeyed up. That's what I'm looking for, right? That's what I'm looking for, okay. And let's give it some space. All right, alter table, go. Good. And then another quick update. Update crap order items set order num equaling to order number. You guys get the gist of what I'm doing here? What I'm trying to do is basically create a column that's got the same information, right? But with a different name. So if I go select asterisk from crap order items now, what should happen is there'll be a column on the left and a column on the right that have the same information. Okay? So far, so good, you guys, especially Khalid. All right, so now I'm going to now do my join with crap order items. So up here, and I don't need that anymore. So up here, I'm going to say, instead of order number, it's going to be order num. So different, oh, Khalid, you should have stopped me. Not the right spot, is it? It's, no, I am right. You didn't have to stop me. I was right. All right. Seed usually for me means customer. So for a minute I freaked out, but I'm okay now. All right. So select orders, whatever. So let's first of all go and demonstrate, is this even possible? So it is possible, right? It is possible to join two tables on column numbers, column names that are not the same, even when their data types are different. So first, I want to dispel that superstition, right? The numbers, the names don't have to be the same. They can be different, and they can be even different data types as long as they resolve. Now let's try something to make it blow up, because I think I can probably make this blow up. Why can I not? Okay, so the alter. So, and I'm going to do this actually for cheap. I'm going to go into here. Yeah, there's scrap order items. I'm going to just edit this without having to type an update. So I'm going to go here to order number. I'm going to change this, and I'm going to make it an, actually, you know what? I'll just go straight AAA. Okay, so that now is a string. Okay, I'm going to save the change or commit the transaction. And there it is. It's now been committed. Okay, so let's go to here, right? Move this down. Boy, I can't get over there. Can I just do that, please? Okay, good. And let's do the join. So now what's going to happen? So you got to pay attention a little bit to the error that's coming out. So the way I would fix this, if I couldn't guarantee that this was a number, if I just did this and converted that to a character string, this should work. Right? I don't have everybody, by the way. I've lost an order, but it worked in that it did the join, right? But it failed because it just could not resolve that as a number. That's an example of what could have happened. So, Kali, we might want to look a little bit more at whatever the problem was. But I did want to take the class through that idea of different names don't matter, different data types don't matter. What matters is the actual join condition, whether it can resolve itself. And this one.
Yeah, I was going based off, the foreign to, primary to foreign or foreign to primary.
Mhm.
That one worked. And on some of the problems that I was working online, it said that, there are two columns with different names, different data types, connect them. I did this exact way. I mean, I Googled it, but I mean,
Okay.
I error. So I was like kind of wondering.
Yeah. Well, again, I'm not going anywhere, so if you want to show me that, that's fine. But yeah, but definitely, there's a lot of times tables are developed by different people at different times and all that kind of stuff. And if you don't have standards in your shop, you'll see all sorts of examples of people just naming them whatever. And then this is why don't depend on the name, but always be aware of what the relationship actually is between the two, right? Which you can usually find by querying the database directly or just or looking at a model or talking to somebody.
Yeah, that makes sense. Got it. Thanks.
Anybody else? So promise me, I know that this is a long term and the last thing you want to do is do any work when this is finished, because we're nearly at the end. We're getting close to the end. But bookmark some of these ideas and return to them later, because the more people that go out into the world that know more about these analytic functions or the more advanced groupings, the better place you'll be. It was so exciting for me when I went to Blue Cross and I looked at some of their code and I saw these. They were actually in their code and I went, aha! So this actually does exist outside of Oracle. So they are definitely out there. So at least understand what you're looking at. And the concern about what the heck does over mean, Major, I spent like months trying to figure that one out. Like what does that actually, like, it seems so weird, but that's an actual ANSI standard way to do an analytic function to define it. So I've just kind of taken it to basically say, do this function over this, condition or idea. That's kind of what that meant to me. And always when I'm coding it, by the way, I like to indent them as well, right? I don't like to squish them all up into one line. Okay, well, that's all I got. So let's, before I say, I know I just said that's all, I am teasing you here, but the dates, we're actually here now, right? We're in the supposed lab, but we're not in a lab now. So next week is subqueries, which I introduced today, but I'm going to talk a little bit more. I do mean a little bit because I want to talk, there's certain things you can do with subqueries, so I want to talk about those. I do want, the merge is super important in the world, especially in the world of data warehousing. So that's why I want to spend more time on the merge. But the merge is yet another DML statement. So far you had the inserts, the updates, and the deletes. Now merge is coming in, and we're going to talk about that. And then views are also important. And I can see why they put views here, because subqueries are kind of like views, and they even got a name that's almost like a view. So we'll talk about those. And then after that, for the beginning of May, my plan is to basically just sit here and help you guys with your projects. That is basically my plan. So for those of you that are having trouble trying to get all your code together, or maybe you're not sure if you're putting it in the right structure or whatever, the whole point of May 5th is just, I'll just sit here, maybe on another machine, I don't know, but I'll just sit here and I will dedicate some time. And then on May 12th, I want to make sure you guys have times to share with each other what you actually did. And if you remember, the way that works is you have your use case, like I want a database that tracks my shoes. And then you actually show the image of your model. And then you just talk about one or two interesting learning points you got from that. Like, hey, I wasn't sure if I should keep my shoes as pairs or independent, or I realized later that sizes were important, or something like that. That's the kind of thing I want you guys to do as sort of your last thing. Any questions?
Yeah, it's Grant. I actually did have a question.
Go ahead, Henry.
So for the final prompt, should we like add in any joins or anything like that?
So when you are, there's one more piece of your project that you don't know yet, and that's how to do a view, right? In the view, you're going to create in the end one more object at the end of your script, and I kind of actually have that in my example. just go down to this, or up to this. So cars and drivers. So this is the setup. Okay. All right. So remember, this is the example I took you guys through on that quick little explanation. Now, way at the bottom, I have a SQL statement, which I then made a view. So that's really the last thing. And you know, several of you now have mentioned this. I'll point out like 3 tables I want you guys to focus on, because typically what it is you'll have a table like cars, you'll have a table like drivers, and then I'm looking for something that connects them, like car mileage, right? Or in this case, you know, whatever, car drivers. And then so where this join stuff comes in, or aggregates or whatever, is you could basically create a nice little query that connects your tables together, and then you're going to create a view on it, and we'll talk about that next week. But other than that, the subject of joins doesn't really come up in your project except right here in the views or your own investigation. All right, I'm going to stop recording as we're obviously in the sort of the questions here, and I'll bid you guys a good night, and I'll hang around until the last person leaves.